Introduction to Communication Network. In this video, we are going to see about Introduction to Communication Network. Introduction to Communication Network. Computers are connected by many different technologies. A network is two or more computers that can interconnect in a peer-to-peer or client-to-server fashion, most often over a shared and virtual connection. In other words, networks provide the connection between computer resources in order to accommodate the flow of information. This is in direct contrast to the old terminal-to-host hardwired connection. A network can still support terminal-to-host connections via terminal emulators or terminal servers, but provides much greater flexibility in switching connections. The downside of this exploding information sharing is the rather annoying situation when one computer wants to expand its information system to another computer that happens to have a different network technology and different network protocols. As a result, even if they could agree on a type of network technology to physically interconnect the two computers at different locations, their applications still would not be able to communicate with each other because of the different protocols. A very basic question arises about the requirement of networks. This may be justified with the help of following points. Sharing of resources can be done easily. Reliability. There is no central computer, so if one breaks down, we can use others. The term networking applies to the exchange of information among individuals, groups, or institutions. The process of electronic voice or data communications. Communication networks are broadly categorized into three types: are local area network (LAN), metropolitan area network (MAN), wide area network (WAN). Switching techniques. In this video, we are going to see about switching techniques. Switching techniques. A network consists of many switching devices. In order to connect multiple devices, this interconnection between computers allows the computers to share the data and interact with each other. Sometimes the computer network thus defined is also known as a shared network. A switched network is made up of a series of interconnected nodes called switches. These switching functions can be performed on interconnected computers by the following switching techniques: circuit switching, packet switching, message switching. Circuit switching. In this video, we are going to see about circuit switching. Circuit switching is the most familiar technique used to build a communication network. Communication via circuit switching implies that there is a dedicated communication path between the two stations. The path is connected through a sequence of links between network nodes. For each physical layer, a logical channel is dedicated to the connection. It is commonly used for ordinary telephone calls where the caller sends a special message with the address of the callee to state its destination. The transmission of information on circuit switched networks usually occurs in three phases: setup phase, data transfer phase, teardown phase. Setup phase. This detects a subscriber's request for a service, identifies the terminal, searches and grabs a unit, informs the required terminal, receives its response, and after the data is transmitted, de-establishes the circuit. Data transfer phase. After the establishment of the dedicated circuit, that is channels, the two parties can transfer data. Teardown phase. After the communication is completed, the linked channels and shared devices are released. As circuit switching systems require a dedicated circuit before the data can be sent, this technique is inefficient and uneconomical. In the first phase, we have to send a signal from the source to the destination to establish the circuit. Once a circuit is established, the data is sent from source to destination. For short distances, the propagation times of signals may be small, but for long distances, sometimes the total setup time may become significant. Thus, this technique is not useful for the applications which require minimum setup time, for example, credit card information, police recording, and retrieving of social security number. The circuit switched networks are not as efficient as the other two types of networks because resources are allocated during the entire duration of the connection. Although a circuit switched network normally has a low efficiency, the delay in this type of network is minimal. During data transfer, the data are not delayed at each switch. The resources are allocated for the duration of the connection. Advantages of circuit switching. The dedicated path or circuit established between sender and receiver provides a guaranteed data rate. Once a circuit is established, data is transmitted without any delay. Since a dedicated continuous transmission path is established, the method is suitable for long continuous transmission. Disadvantages of circuit switching. As the connection is dedicated, it cannot be used to transmit any other data even if the channel is free. It is inefficient in terms of utilization of system resources. Dedicated channels require more bandwidth. Prior to actual data transfer, the time required to establish a physical link between the two stations is too long. Packet switching. In this video, we are going to see about packet switching. Packet switching is the most commonly used technique for data communication in wide area network. It works on the same principle of the message switching techniques, but in this, the message is divided into subsets of equal length called packets. In packet switching, the message is divided into blocks of fixed size, and each packet has its own control information regarding the routing. In packet-switched networks, if any node receives a garbled packet, it will request the sending node to transmit the same packet again. When the destination node receives the last packet of the message, it sends an acknowledgement to the source code. Similarly, if the destination node does not receive all the packets within the specified time, it sends a request for the data to the source node about the missing packets. After the receiving node receives the missing packet, it does not send the acknowledgement. The packet switching technique allows the switching nodes to transmit the packets without waiting for a complete message and also allows them to adjust the traffic they have, thus minimizing the resource requirement of the nodes. The packet switching method uses two routing approaches: datagram packet switching, virtual circuit packet switching. Advantages of packet switching. High data transmission quality. The other advantage is that the packet switching is more fault tolerant. Disadvantages of packet switching. Packets may be lost on their route, so the sequence numbers are required to identify missing packets. Switching nodes require more processing power as the packet switching protocols are more complex. Switching nodes for packet switching requires large amounts of RAM to handle large quantities of packets. A significant data transmission delay occurs. Use of store and forward method causes a significant data transmission. Datagram packet switching. In this video, we are going to see about datagram packet switching. Datagram-based packet switching is the fundamental technique used in the Internet for end-to-end routing of packets at the network layer between remote communicating computers. In datagram-based switching, data is split into smaller units and a header containing source and destination addresses is added to each small unit to form packets. The packets of a flow are given to the network and the network treats each packet independently and routes the packet using the packet header alone. Since each packet is routed independently, packets from the same source to the same destination may traverse through different paths. As a result, the packets may arrive at the destination out of order. When this occurs, the packets will have to be reassembled to form the original message. There are three primary types of datagram packet switches: store and forward, fragment-free, cut-through. Store and forward buffers data until the entire packet is received and checked for errors. This prevents corrupted packets from propagating throughout the network but increases switching delay. Fragment-free filters out most error packets but does not necessarily prevent the propagation of errors throughout the network. It offers faster switching speeds and lower delay than store and forward mode. Cut-through does not filter errors, it switches packets at the highest throughput, offering the least forwarding delay. Virtual circuit. In this video, we are going to see about virtual circuit. In virtual circuit packet switching, a fixed path between a source and a destination is established prior to transfer of packets. As in circuit switching, the virtual circuit setup procedure usually takes place before any packets can flow through the network. Connection-oriented network is also known as virtual circuit. The virtual circuit is similar to the telephone system. A route which consists of a logical connection is first established between two users. The process is completed in three main phases: establishment phase, data transfer phase, connection release phase. Establishment phase. During setting up of logical connection, the two users not only agree to set up a connection between them, but also decide upon the quality of service associated with the connection. After this, the sequences of packetized information are transmitted bidirectionally between the nodes. The information is delivered to the receiver in the same order as transmitted by the sender. Data transfer phase. During this phase, it performs flow control and error control services. The error control services ensures correct sequencing of packets and the correct arrival of packets. Connection release. When the station wishes to close down the virtual circuit, one station can terminate each connection with a clear request packet. Permanent virtual circuit. A permanent virtual circuit (PVC) is a software-defined logical connection in a network such as a frame relay network. A feature of frame relay that makes it a highly flexible network technology is that users, companies, or clients of network providers can define logical connections and required bandwidth between endpoints and let the frame relay network technology worry about how the physical network is used to achieve the defined connections and manage the traffic. In frame relay, the endpoints and a stated bandwidth called a committed information rate, that is CIR, constitute a PVC which is defined to the frame relay network devices. Connectionless and connection-oriented communication. In this video, we are going to see about connectionless and connection-oriented communication. Connectionless communication. In telecommunication, connectionless describes communication between two network endpoints, which a message can be sent from one endpoint to another without prior arrangement. Connectionless protocol does not require an initial handshake or acknowledgement to be sent in every packet. The Internet Protocol and User Datagram Protocol are connectionless communication. Connectionless protocols are usually described as stateless because the endpoints have no protocols defined way to remember where the conversations of message exchanges. Walkie-talkies or citizens band radios are a good example of connectionless communication. Connection-oriented communication. In telecommunication, connection-oriented describes a means of transmitting data in which the devices at the endpoint use a preliminary protocol to establish an end-to-end connection before data is sent. Connection-oriented protocols are sometimes called as reliable network because it guarantees that data will arrive in proper sequence. Transmission Control Protocol is a connection-oriented protocol. For connection-oriented communication, each endpoint must be able to transmit so that it can communicate. Message switching. In this video, we are going to see about message switching. In message switching, if a station wishes to send a message to another station, it first adds the destination address to the message. Message switching does not establish a dedicated path between the two communicating devices, that is, no direct link is established between sender and receiver. Each message is treated as an independent unit. In message switching, each complete message is then transmitted from device to device through the internetwork, that is, the message is transmitted from the source node to intermediate node. The intermediate node stores the complete message temporarily, inspects it for errors, and transmits the message to the next node based on an available free channel and its routing information. Because of this reason, message switched networks are called store and forward network. The actual path taken by the message to its destination is dynamic as the path is established as it travels along. When the message reaches a node, the channel on which it came is released for use by another message. The first electromechanical telecommunications system used message switching for telegrams. The message was punched on paper tape offline at the sending office and then read on and transmitted over a communication line to the next office along the way, where it was punched out on paper tape. Delay in message switching. A message switch network consists of store and forward switches interconnected by trunks. A single trunk is usually sufficient between a pair of switches. Multiple trunks can be provided to increase reliability. The basic operation of the store and forward service is similar to the telegram service. A message along with the destination address is sent from switch to switch till it reaches the destination. Switch 1 accepts the message and analyzes the destination address. A routing table is maintained at each node. It contains entries indicating destination nodes and the corresponding outgoing trunks from the switch. There is a separate queue for each trunk. Since the destination node may be accessible via more than one route, decision to send the message to a particular next switch depends on the expected delay in its queue. The message received at switch 2 is again put in a queue of messages awaiting transmission to switch 4. When its turn comes, the message is sent to switch 4, which delivers it to the destination. The store and forward service is unidirectional. After delivery of the message, the network does not send back any confirmation of the source. If end system B is required to send an acknowledgement to the message received from A, the acknowledgement is treated like any other message by the network and carries the addresses of the destination and the source. To switch transfer of the message, the network may employ some error control mechanism. The message may be appended with error checking bits, and if any error is detected by the receiving switch, it may request the sending switch for retransmission of the message. Therefore, the sending switch is required to keep a copy of the message till an acknowledgement is received. Since a message is stored in a buffer at the switch at each stage of transmission, each switch-to-switch transfer is an independent operation. The trunks can operate at different data rates. In message switching, every message is treated as an independent entity by the network, and therefore destination and source addresses are repeated on each message. Advantages of message switching: efficient traffic management, reduces network traffic congestion, efficient use of transmission channel. Disadvantages of message switching: transmission delay is deduced due to store and forward. Each node requires large capacity for storing. Cell switching, that is ATM. In this video, we are going to see about cell switching, that is ATM. Asynchronous Transfer Mode (ATM) is a streamlined packet transfer interface. ATM also is a connection-oriented network. ATM uses packets of fixed size for communication of data. These packets are called as ATM cells. ATM is used for efficient data transfer over high-speed data networks. ATNI provides real-time and non-real-time services. The services provided are synchronous TDM streams such as T1, services using the constant bit rates, compressed voice and video, traffic with specific quality requirement using the non-real-time variable bit rate. IP-based services using available bitrate ABR and unspecified bitrate UBR services. The ATM needs an adaptation layer for supporting the information transfer protocols that are not based on ATM. Cell relay. ATM is also known as cell relay. It has advantages of better reliability and fidelity, which allows faster packet switching than X.25. Applications. ATM was developed as a part of work on ISDN. But now it is used in non-ISDN system where the data rates are very high. ATM protocol architecture, that is ATM reference model. ATM is a streamlined protocol. It has minimal error and flow control capabilities. Hence, the number of overhead bits required with each cell is reduced, which enables ATM to operate at high data rates. Also, due to the ATM cells of fixed size, the processing requires at each node is simplified. This also supports the use of ATM at high data rates. ATM protocol architecture for an interface between user and network. Layers in the ATM protocol model are physical layer, ATM layer, ATM adaptation layer, that is AAL, physical layer. The physical layer of the protocol involves the specification of a transmission medium and encoding scheme. The data rates specified at this layer are between 25.6 Mbps and 622.08 Mbps, but data rates higher and lower than these are possible. ATM layer. This layer is common to all the services that provide the packet transfer capabilities. This layer defines the transmission of data in fixed size cells, and it also defines the use of logical connections. ATM adaptation layer AAL. This layer is a service-dependent layer. It is used for supporting the information transfer protocol not based on ATM. The AAL maps the higher layer information onto the ATM cell, and cell is transported over the ATM network. Planes in the ATM protocol model are user plane, control plane, management plane. User plane. It is used for transferring user information along with associated controls such as flow control, error control, etc. Control plane. It is supported to perform the call control and connection control functions. Management plane. It includes the plane management. The management plane performs management functions related to a system. They include provision of coordination between all planes, layer management, management function relating to resources and parameters residing in its protocol entities. Telephone network signaling. In this video, we are going to see about telephone network signaling. The telephone network at its beginning used a circuit switch network with its dedicated links to transfer voice communication. The modern telephone network provides two-way, real-time transmission of voice signals. Each telephone has two copper wires coming out of it that directly connect to the telephone company's nearest end office. The two-wire connection between each subscriber's telephone and the end office are known in the trade as the local loop. When the phone is not in use, called on hook, it looks like an open circuit, where a phone receiver is lifted from the cradle switch. The circuit to the local office is completed. A current of about 200 milliamps flows through this loop from a battery at the phone office. The presence of this flow tells the office that the phone has gone off the hook. It provides dial tone to the user. Dialing involves rapidly opening and closing the loop. The phone office senses and could not open and close pulse to see what number is being dialed. Modern tone dialing phones do not open and close the loop, but instead put tones on the wire pair to the phone office, which has special circuitry to detect the tones. To set up a call, the source switch uses the telephone signaling network to find a route and allocate resources across the network to the destination office. The destination office next alerts the destination user of an incoming call by ringing the phone. This ring is sent back to the source telephone, and the conversation can begin when the destination phone is picked up. A variety of transmission media are used for telecommunication. Local loops consist of twisted pairs between switching offices. Coaxial cables, microwaves, and especially fiber optics are widely used. The voice signal flows in analog form from the telephone to the telephone office. The voice signal is converted into digital form using PCM at the line card interface where the copper wires connect to the local telephone switch. The digitized voice signal flows from that point onward as a sequence of PCM samples over a path that has been set up across the network. Dialing is accepted only as a response of dial tone. There are two types of dialing facilities available: pulse dialing, tone dialing. Pulse dialing. The idea of pulse dialing is to make the phone generate a number of on-off pulses corresponding to the digit being dialed by the user. The on-off pulses are generated by the phone dial actually opening and closing the loop circuit from the telephone office at a fixed rate. Recall that the loop from the telephone office is open when the phone is on hook. When the phone is off hook, the loop circuit is closed. The number of open-close cycles is equal to the desired digit. Tone dialing. It uses tones instead of pulse. Each dialed digit is represented by a unique pair of sine wave tones, and the tone pair is sent to the phone company office as each digit to be dialed is pushed on the phone. When a key corresponding to a digit is pushed, the tones for its row and column are transmitted. The technical name for this scheme is dual tone multifrequency, that is DTMF. Network topologies. In this video, we are going to learn about network topologies. A network is a set of devices interconnected by a communication medium. Each device is referred to as a node. A node can be a computer, printer, or any other computing device. The manner in which nodes are geometrically arranged and connected is known as a topology of the network. Physical topology of a local area network should have the following desirable features. The topology should be flexible to accommodate changes in physical locations of the stations, increase in the number of stations, and increase in the land geographic coverage. The cost of physical media and installation should be minimum. The network should not have any single point of complete failures. Types of topologies in network: bus topology, ring topology, star topology, mesh topology. Bus topology. In this video, we are going to learn about bus topology. Bus topology, also called horizontal topology. In bus topology, multiple devices are connected one by one by means of a single cable. Bus is passive topology because it requires termination. The central cable is the backbone of this network and is known as a bus. When one computer sends a signal up the wire, all the computers on the network receive the information, but only one accepts the information, the rest discard the messages. Advantages: easy to use and easy to install. Needs fewer physical connectivity devices. A repeater can also be used to extend a bus topology network. Low cost. Disadvantages: Heavy network traffic can slow a bus considerably. It is difficult to troubleshoot a bus. Failure of a cable affects all devices on the network. Difficult to add new node. Star topology. In this video, we are going to learn about star topology. A star topology consists of a number of devices connected by point-to-point links into a central hub. In star topology, every node, that is computer workstation or any other peripheral, is connected to a central node called a hub or switch. A star network consists of one central switch, hub or router, which acts as a conduit to transmit messages. All peripheral nodes may thus communicate with all others by transmitting to and receiving from the central node only. Advantages: it is easy to modify and add new nodes to a star network without disturbing the rest of the network. Centralization allows the inspection of traffic through the network. Easy to detect faults and to remove parts. Installation and configuration is easy. Failures of any node do not bring down the whole star network. Disadvantages: if the central hub fails, the whole network fails to operate. Each device requires its own cable segment. Requires a large amount of cable to be connected. Token ring topology. In this video, we are going to learn about token ring topology. In a ring topology, each computer is connected to the next computer, with the last one connected to the first. Data travel from node to node, with each node along the way handling every packet. The signals travel on the cable in only one direction. Each computer retransmits what it receives. Because a ring topology provides only one pathway between any two nodes, ring networks may be disrupted by the failure of a single link. Ring is an active network. In this, termination is not required. Advantages: cable failures are easily found. Performs better than a bus topology under heavy network load. Does not require a central node to manage the connectivity between the computers. It is quite easy to install and reconfigure, since adding or removing a device requires moving just two connections. Disadvantages: adding or removing nodes disrupts the network. It is difficult to troubleshoot a ring network. Failure of one node on the ring can affect the whole network. Cost of cable is more in ring network. Mesh topology. In this video, we are going to learn about mesh topology. The mesh topology has a link between each device in the network. All nodes cooperate in the distribution of data in the network. A mesh network can be designed using a flooding technique or a routing technique. When using a routing technique, the message is propagated along a path by hopping from node to node until the destination is reached. A mesh network whose nodes are all connected to each other is a fully connected network. Fully connected wired networks have the advantages of security and reliability. Problems in a cable affect only the two nodes attached to it. Mesh networks are easy to troubleshoot. Much of the bandwidth available in mesh configuration is wasted. Rather, they are hybrid mesh networks which contain some most important sites with multiple links. Advantages: data can be transmitted from different devices simultaneously. This topology can withstand high traffic. Even if one of the components fails, there is always an alternative present, so data transfer does not get affected. Expansion and modification in topology can be done without disrupting other nodes. Troubleshooting is easy. Disadvantages: there are high chances of redundancy in many of the network connections. Overall cost of this network way is too high as compared to other network topologies. Setup and maintenance of this topology is very difficult. Even administration of the network is tough. Difficulty of installation. Layering the communication process. In this video, we are going to see about layering the communication process. Open System Interconnection, that is OSI, was set up as an international standard for network architecture. The International Organization for Standardization, that is ISO, took the initiative in setting OSI. OSI has two meanings. It refers to protocols that are authorized by ISO, OSI Basic Reference Model. The OSI reference model divides the required functions of the network architecture into several layers and defines the function of each layer. Physical data encoding. Information exchanged between two computers is physically by means of electrical signals, assuming certain coding methods. These coding can be characterized by changing voltage levels, current levels, frequency of transmission, phase changes, or any combination of these physical aspects of electrical activity. Over time, network vendors defined different standards for encoding data on the wire. One such standard, namely bipolar data encoding. In bipolar encoding, binary data are simply represented by the actual signal level, in which a binary 1 is encoded using a fixed voltage level, for example positive 5 volts, and a binary 0 is encoded using a negative level, for example negative 5 volts. Transmission media. This deals with the type of media used. fiber, copper, wireless, and so on, which is dictated by the desirable bandwidth, immunity to noise, and attenuation properties. These factors affect the maximum allowable media length while still achieving a desirable level of guaranteed data transmission. Data flow control. Data communications process allocates memory resources, commonly known as communications buffers, for the sake of transmission and reception of data. A computer whose communication buffers become full while still in the process of receiving data runs the risk of discarding extra transmissions and losing data unless a data flow control mechanism is employed. A proper data flow control technique calls on the receiving process to send a stop sending signal to the sending computer whenever it cannot cope with the rate at which the data is being transmitted. The receiving process later sends a resume sending signal when data communications buffers become available. Data frame format. Information exchange between computers' communication process need to have the following for accomplishing these aspects of the exchange process. Receiving computer must be capable of distinguishing between an information carrying signal and mere noise. There should be a detection mechanism to detect whether the information carrying signal is intended for itself or any other computer on the network, or a broadcast, a message that is intended for all the computers on the network. If the receiving end engages in the process of recovering data from the medium, it needs to be able to recognize where the data train intended for the receiver ends. After this determination is made, the receiver should discard subsequent signals unless it can determine that they belong to a new impending transmission. The receiving end, after completion of information, must also be capable of dealing with and recognizing the corruption, if any, introduced in the information due to noise or electromagnetic interference. To accommodate the above requirements, the data is delivered in a well-defined package called data frame. The receiving end compares the contents of this data frame. If the comparison is favorable, the contents of the information field are submitted for processing. Otherwise, the entire frame is discarded. It is important to realize that the primary concern of the receiving process is the reliable recovery of the information embedded in the frame. Routing. As networks grow in size, so does the traffic imposed on the wire, which in turn impacts the overall network performance, including response. To alleviate such degradation, network specialists resort to breaking the network into multiple networks that are interconnected by specialized devices including routers, bridgers, routers, and switches, as shown. The routing approach calls for the implementation of various cooperative processes in both routers and workstations whose main concern is to allow for the intelligent delivery of data to its ultimate destination. Exchange of data can take place between any two workstations whether or not both belong to the same network. Open System Interconnection, that is OSI model. In this video, we are going to see about Open System Interconnection, that is OSI model. The International Organization for Standardization developed the Open System Interconnection, that is OSI reference model. OSI model is the most widely used model for networking. OSI is a 7-layer standard. The OSI model does not specify the communication standard or protocols to be used to perform networking tasks. Services provided by OSI model provides peer-to-peer logical services with layer physical implementation. Provides standards for communication between systems. Defines point of interconnection for the exchange of information between systems. Each layer should perform a well-defined function. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer, narrows the point in order to increase the ability to communicate without expansive conversions and translations between products. Principles used in defining OSI layers. Do not create so many layers as to make the system engineering. The task of describing and integrating the layer is more difficult than necessary. Create a boundary at a point where the description of services can be small and the number of interrelations across the boundary is minimized. Create separate layers to handle functions that are manifestly different in the process performed. Collect similar functions into the same layer. Select the boundaries at a point which past experience has demonstrated to be successful. Create a layer of easily localized function so that the layer could be totally redesigned and its protocol changed in a major way to take advantage of new advances in architecture, hardware, or software technology without changing the services expected from and provided to the adjacent layers. Create a boundary where it may be useful at some points in time to have the corresponding interface standardized. Create for each layer boundaries with its upper and lower layer only. OSI Model Layers. In this video, we are going to learn about layers of OSI model. OSI layers basically consist of 7 layers as follows. OSI Model Layers. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Physical layer. It is the lowest layer of the OSI model. This layer transmits raw bits over a communication channel. The design issue of physical layer considers 4 factors: electrical, mechanical, procedural attributes, function attributes. The electrical attributes describe the voltage level or current level. The mechanical attributes describe the connectors and the wires of the interface. The procedural attributes describes what connectors must do and the sequence of events required to effect actual data transfer across the interface. The functional attributes describe the function to be performed by the physical interface. Data link layer. It is responsible for the transfer of data over the channel. It groups zeros and ones into frames. A frame is a series of bits that forms a unit of data. DLL detects and corrects the transmission errors using error correction method. It also provides data flow control to ensure that the DTE does not become overburdened. It identifies the devices on the network. Network layer. It specifies the intra-network operations and different types of addressing and routing services. Logical and service addressing are provided from network layer. It also provides switching control and terminal connections. The X25 specification is included in this layer. Transport layer. It is responsible for reliable end-to-end data transfer. Hence, the optimum utilization of network resources occurs. The transport layer performs the service of sending and receiving segments of data to session layer. It also provides flow control, sequence numbering, and message acknowledgement. Session layer. It adds mechanisms to establish, maintain, synchronize, and manage communication between network entities. This layer has specific services, primitives, and protocol data unit which are defined in ISO. Presentation layer. It is responsible for data compression, data expansion, data encryption, and data decryption. It accepts data types int, char, etc. from application layer and then negotiate with its peer layer as to the syntax representation. Application layer. It supports end-user functions like login, password, and file transfer. This layer contains service elements to support application processes such as job management, financial data exchange, and business data exchange. This layer also supports virtual terminal and virtual file concepts. OSI Model Layers functions. In this video, we are going to see about OSI Model Layers functions. User A sent the information to the application layer, which is closest to the end user. That means both the OSI application layer and the user interact directly with the software application. Application layer uses SMTP commands to tell the server how to handle the data. The presentation layer works to alter into a form that the application layer can read. It will format and encrypt the data to be sent over the network. Session layer establishes, manages, and ends communication connections between applications. It controls whose turn it is to communicate, and if it is allowed to communicate simultaneously, it will manage things between each node. The transport layer accepts data from the session layer, ensures complete data transfer by breaking it down into things called segments, and sends to network layer. In network layer, segments become packets by adding destination IP address and source IP address. Data link layer encodes and decodes data packets into bits. The encapsulated data, that is packet, is actually placed inside a data frame. The data link layer is responsible for data movement across the actual physical link to the destination node. The frames are converted into a single bit stream as they are passed to the physical layer from the data link layer. This means that bits are queued up one by one as they move on to the network media. Data encapsulation. In this video, we are going to see about data encapsulation. Data encapsulation simply means adding the IP header to the data. The IP header consists of 5 or 6 32-bit words. The 6th word is attributed to the IP options field. Internet header length, that is IHL. IP determines the length of the header by the contents of the IHL. The version field. It refers to the version of the IP protocol in use. The current version of IP is 4. The service type field. It refers to any of the type of services that IP supports. Desired service type is normally specified by user-level applications. The total length field. If it is subtracted from the IHL field, it indicates to IP the actual length of the data field. The identification and the fragment fields. These provide the necessary elements on which IP's capability to fragment and reassemble data depends. Header checksum field. IP supports a header checksum field in its header, though it is an unreliable protocol. IP uses this field to check the integrity of its own header only. If it does not pass the integrity check, the entire datagram is discarded. The time to live field, that is TTL field. TTL is employed by IP to prevent a lost datagram from endlessly looping around the network. Every time the datagram traverses a router, IP decrements the TTL field by 1. The source and destination IP addresses. These provide the identification for the receiving and the communicating hosts across the internetwork. IP options field. On its presence, it includes optional control information. Protocol. In this video, we are going to see about protocol. In information technology, a protocol is a special set of rules that endpoints in a telecommunication connection use when they communicate. Protocols specify interactions between the communicating entities. Protocols exist at several levels in a telecommunication connection. For example, there are protocols for the data interchange at the hardware device level and protocols for data interchange at the application program level. In the standard model known as Open Systems Interconnection, that is OSI, there are one or more protocols at each layer in the telecommunication exchange that both ends of the exchange must recognize and observe. Protocols are often described in an industry or international standard. The TCP/IP Internet protocols, a common example, consists of Transmission Control Protocol, that is TCP, which uses a set of rules to exchange messages with other internet points at the information packet level. Internet Protocol IP, which uses a set of rules to send and receive messages at the internet address level. Additional protocols that include the Hypertext Transfer Protocol (HTTP) and File Transfer Protocol (FTP), each with defined set of rules to use with corresponding programs elsewhere on the internet. There are many other internet protocols such as the Border Gateway Protocol (BGP) and the Dynamic Host Configuration Protocol (DHCP). Services and layering. In this video, we are going to see about services and layering. The interaction of application process running on separate systems and communicating over a network is a complex task requiring a large number of operations. Since many of the operations are common to most processes, they can be grouped and provided as a library of functions called when needed. There are many ways to combine these operations depending upon the needs of the application processes calling them. In networked applications, a layered structure best serves the requirement of grouping operations and finding combinations that work well together to meet a particular need. The layers defined in the suite of network protocols isolate particular services and define the relationship between the services. For example, communication between processes on separate computers requires that message sent from one computer arrive at the other. It is useless to consider message exchange between processes unless that capability exists. By isolating the details of each service from the others, layering allows each service to be developed and revised as needed with minimal impact on the other components of the network software. Some services such as sharing the communication medium change as new technology becomes available. The layer in a protocol suite identifies the required components of each network communication between application processes. Within each layer, a number of choices allow the processes to select the type of service most appropriate for their needs. Each service is defined in terms of its interaction with a layer above it and the net effect of its use. A suite of network protocols consists of a collection of layers of services to support communication between application processes. Each of the layers consists of one or more options for the type of service provided at that layer. The layers are often referred to as a protocol stack. PDU, Protocol Data Unit. In this video, we are going to see about PDU, that is Protocol Data Unit. The PDUs exchanged have two parts: header, also known as the Protocol Control Information (PCI), and payload, also known as a Service Data Unit (SDU). The protocol does not define or constrain the data carried in the payload part. It does specify the format of the PCI, defining the fields which are present and the way in which the patterns of bits are to be interpreted. A protocol also defines the procedure which determine how the PDU will be processed at the transmit and receive nodes. The procedures specify the valid values for the PCI fields and action to be taken upon reception of each PCI value, usually based on stored control information. Examples of procedures which are implemented in protocols include error recovery, for example, the checkpoint procedure, the go back end procedure, flow control, segmentation, service access point selection, connection management. A protocol implemented by several processes represented by circles, communicating using queues of PDs, a shared information area shown as a rectangle, and function calls between the processes represented by arrows. Protocols are usually implemented by writing a number of programs, that is processes, which communicate with one another through queues and by function calls. This interface is also used to request new, that is empty buffers for received PDUs or PDUs created by the layer, and to release buffers which are no longer needed by the protocol. Protocols are generally described using a layered architecture known as the OSI reference model. Examples of protocols include data link layer, HDLC, MAC, ARP, network layer, IP, ICMP, transport layer, UDP, TCP. The data transmission software or protocols perform the following functions for the efficient and error-free transmission of data: data sequencing, data routing, flow control, error control. Data sequencing. A long message to be transmitted is broken into smaller packets of fixed size for error-free data transmission. Data routing. It is the process of finding the most efficient route between source and destination before sending the data. Flow control. All machines are not equally efficient in terms of speed, hence the flow control regulates the process of sending data between fast sender and slow receiver. Error control. Error detecting and recovering is one of the main functions of communication software. It ensures that data are transmitted without any error. SDU, that is Service Data Unit. In the Open Systems Interconnection, that is OSI terminology, a Service Data Unit SDU is a unit of data that has been passed down from an OSI layer to a lower layer. It is a set of data that is sent by a user of the services of a given layer and is transmitted semantically unchanged to a peer service user. It differs from a PDU in that the PDU specifies the data that will be sent to the peer protocol layer at the receiving end, as opposed to being sent to a lower layer. The SDU at any given layer, layer n, is the PDU of the layer above, layer n+1. In effect, the SDU is the payload of the given PDU. That is, the process of changing a SDU to a PDU consists of an encapsulation process performed by the lower layer. All the data contained in the SDU becomes encapsulated within the PDU. The layer n-1 adds headers or footers or both to the SDU, transforming it into a PDU of layer n-1. The added headers or footers are part of the process used to make it possible to get data from a source to a destination. TCP/IP suite. In this video, we are going to see about TCP/IP suite. TCP/IP suite. The TCP/IP protocol suite was developed prior to the OSI model. Therefore, the layers in the TCP/IP protocol suite do not exactly match those in the OSI model. The original TCP/IP protocol suite was defined as having 4 layers: host to network, internet, transport, and application. However, when TCP/IP is compared to OSI, we can say that host to network layer is equivalent to the combination of the physical and data link layers. The internet layer is equivalent to the network layer and application layers, with the transport layer in TCP/IP taking care of the part of the duties of the session layer. We assume that the TCP/IP protocol suite is made up of 5 layers: physical, data link, network, transport, and application. The first 4 layers provide physical standards, network interfaces, internetworking, and transport functions that correspond to the first 4 layers of the OSI model. The 3 topmost layers in the OSI model, however, are represented in TCP/IP by a single layer called the application layer. At the transport layer, TCP/IP defines 3 protocols: Transmission Control Protocol, that is TCP, User Datagram Protocol, that is UDP, and Stream Control Transmission Protocol, that is SCTP. At the network layer, the main protocol defined by TCP/IP is the Internetworking Protocol, that is IP. There are also some other protocols that support data movement in this layer. Physical and data link layers. At the physical and data link layers, TCP/IP does not define any specific protocol. It supports all the standards and protocols. A network in a TCP/IP internetwork can be a local area network or a wide area network. Network layer. At the network layer, or more accurately the internetwork layer, TCP/IP supports the Internetworking Protocol. IP in turn uses 4 supporting protocols: ARP, RARP, ICMP, and IGMP. Each of these protocols is described in greater detail in later chapters. Internetworking Protocol IP. The Internetworking Protocol IP is the transmission mechanism used by the TCP/IP protocols. It is an unreliable and connectionless protocol, a best effort delivery service. The term best effort means that IP provides no error checking or tracking. IP assumes the unreliability of the underlying layers and does its best to get a transmission through to its destination, but with no guarantees. IP transports data in packets called datagrams, each of which is transported separately. Datagrams can travel along different routes and can arrive out of sequence or be duplicated. IP does not keep track of the routes and has no facility for reordering datagrams once they arrive at their destination. Address Resolution Protocol. The Address Resolution Protocol (ARP) is used to associate a logical address with a physical address. ARP is used to find the physical address of the node when its internet address is known. Internet Control Message Protocol. The Internet Control Message Protocol (ICMP) is a mechanism used by hosts and gateways to send notification of datagram problem back to the sender. ICMP send query and error reporting messages. Internet Group Message Protocol. The Internet Group Message Protocol (IGMP) is used to facilitate the simultaneous transmission of a message to a group of recipients. Transport Layer. Traditionally, the transport layer was represented in TCP/IP by two protocols, TCP and UDP. IP is a host-to-host protocol, meaning that it can deliver a packet from one physical device to another. UDP and TCP are transport-level protocols responsible for delivery of a message from a process that is running program to another process. A new transport layer protocol, SCTP, has devised to meet the needs of some newer applications. User Datagram Protocol. The User Datagram Protocol (UDP) is the simpler of the two standard TCP/IP transport protocols. It is a process-to-process protocol that adds only port addresses, checksum error control, and length information to the data from the upper layer. Transmission Control Protocol. The Transmission Control Protocol (TCP) provides full transport layer services to applications. TCP is a reliable stream transport protocol. The term stream in this context means connection-oriented. A connection must be established between both ends of a transmission before either can transmit data. At the sending end of each transmission, TCP divides a stream of data into smaller units called segments. Each segment includes a sequence number for reordering after receipt, together with an acknowledgement number for the segment received. Segments are carried across the internet inside of IP datagrams. At the receiving end, TCP collects each datagram as it comes in and reorders the transmission based on sequence numbers. Stream Control Transmission Protocol. The The Stream Controls Transmission Protocol, that is SCTP, provides support for newer applications such as voice over the internet. It is a transport layer protocol that combines the best features of UDP and TCP. Application layer. The application in the TCP IP is equivalent to the combined session, presentation, and application layers in the OSI model. Many protocols are defined at this layer. Hourglass model. In this video, we are going to see about hourglass model. An important aspect of this network architecture is that there is a single network layer protocol. Internet Protocol version 4, that is IPv4, is the only network protocol used in the current internet, with the exception of Internet Protocol version 6, IPv6, which is being deployed incrementally. This hourglass architecture shows the 5 protocol layers of the internet and a selection of protocols for each layer. In the network layer, there is only one protocol, the Internet Protocol, that is IP. The restriction to IP at the network layer and the diversity of protocols in other layers give the hourglass architecture its shape. The restriction of using a single network protocol is necessary to ensure interoperability between all network systems in the network. With a layered protocol stack, however, it is possible to support diversity at layers above and below the network layer. For example, numerous different link layer protocols are in use to provide point-to-point connectivity between neighboring systems. Because the link layer is limited to neighboring systems, it is easily possible to deploy novel link layer protocols, for example, wireless network access. Similarly, different transport layer protocols use IP as the basis for their operation. Because only the connecting end systems need to be able to understand a specific transport layer protocol, new protocols can be deployed without problems. Internet architecture. In this video, we are going to see about Internet architecture. Internet architecture. The Internet is a complex network and has no fixed topology. Internet service providers, ISPs, are connected to the backbone network. In fact, there are multiple backbone networks. Individual or corporate users access the internet through dial-up or leased lines. Content providers set up servers and connect to ISPs. The internet is a connection of various internets connected through routers, also called gateways. Also, the internet is a very dynamic network. Networks are added and removed almost on a daily basis. Websites crop up and go down also on a daily basis. When a user invokes his browser and enters a URL, how does he get the information? The first requirement is that the server where the resource corresponding to the URL is located has to be known, and the request has to be forwarded to that server. Secondly, when the packets are transmitted from one node to another, the packets have to be routed properly. To get connected to the internet, we need to obtain an account from a local internet service provider, ISP. The ISP has various servers such as mail server, domain name server, web server, and authentication server. We can get access to the ISP server either through a dial-up line or a leased line. We log into the server at the ISP, and the ISP provides access to the rest of the internet through a router or gateway. Protocol overview. In this video, we are going to see about the overview of protocol. The OSI model and any other network communication model provides only a conceptual framework for communication between computers, but the model itself does not provide specific methods of communication. Actual communication is defined by various communication protocols. In the context of data communication, a protocol is a formal set of rules, conventions, and data structure that governs how computers and other network devices exchange information over a network. In other words, a protocol is a standard procedure and format that two data communication devices must understand, accept, and use to be able to talk to each other. In modern protocol design, protocols are layered according to the OSI 7-layer model or a similar layered model. Layering is a design principle which divides the protocol design into a number of smaller parts, each part accomplishing a particular subtask and interacting with the other parts of the protocol only in a small number of well-defined ways. Layering allows the parts of a protocol to be designed and tested without a combinatorial explosion of cases, keeping each design relatively simple. Layering also permits familiar protocols to be adapted to unusual circumstances. The header and/or trailer at each layer reflect the structure of the protocol. Detailed rules and procedures of a protocol or protocol group are often defined by a lengthy document. For example, IETF uses RFCs, that is, requests for comments, to define protocols and updates to the protocols. A wide variety of communication protocols. One of the most popular protocol suites is TCP/IP, which is the heart of internetworking communications. The IP, the Internet Protocol, is responsible for exchanging information between routers so that the routers can select the proper path for network traffic, while TCP is responsible for ensuring the data packets are transmitted across the network reliably and error-free. LAN and WAN protocols are also critical protocols in network communications. The LAN protocol suite is for the physical and data link layers of communication over various LAN media such as Ethernet wires and wireless radio waves. The WAN protocol suite is for the lowest 3 layers and defines communication over various wide area media such as fiber optic and copper cables. Today's new technologies are based on the accumulation over years of technologies, which may be either still existing or obsolete. Because of this, the protocols which define the network communication are highly interrelated. For example, many routing protocols use other network protocols to exchange information between routers. In addition to standards for individual protocols in transmission, there are now also interface standards for different layers to talk to the ones above or below, usually operating system specific. The protocols for data communication cover all areas as defined in the OSI model. A protocol may perform the functions of one or more of the OSI layers, which introduces complexity to understand the protocols relevant to the OSI 7-layer model. To develop a complete technology that is useful for the industry, very often a group of protocols is required in the same layer or across many different layers. Different protocols often describe different aspects of a single communication. Taken together, these form a protocol suite. For example, Voice over IP (VoIP), a group of protocols developed by many vendors and standard organizations, has many protocols across the 4 top layers in the OSI model. Protocols can be implemented either in hardware or software or a mixture of both. Typically, the lower layers are implemented in hardware, with the higher layers being implemented in software. Protocols could be grouped into suites or families or stacks by their technical functions or origin of the protocol introduction, or both.